Hi, my name is Brian Caffo, and this is the lecture on defining success in data science. So let's talk about success versus failure in data science. So the positive results of a data science experiment, the most positive results of a data science experiment, is new knowledge is created. But even better than that is that actionable decisions are made off of that new knowledge. So decisions are made based on the outcome of the data analysis. Ideally, these decisions, the new knowledge, or the product from the data analysis has impact. And I would define another form of success that seems less clearly successful, but still is successful nonetheless, which is if you determine that the data cannot inform the decision in question, or the knowledge that you'd like to gain. If that's conclusive, then you know where else to look. So that is a form of success. Maybe it's a negative form of success, but it is a form of success. Let's talk about the opposite. What are ways in which data science experiments can really be unsuccessful? Well, the decisions are made in the opposite of the direction of clear evidence. That's probably the worst output of a data science experiment, where all the evidence is clear and the decisions are made in the opposite direction. Another problem is that maybe the results are equivocal. So the study is maybe underpowered, or maybe you didn't measure what you would hope to or what you'd like to have measured, and so even though you get conclusive results, the measurement is off by a little bit. So these things can all happen and lead to a result that neither supports nor refutes a set of hypotheses. Also, in these cases, the decision would not be obvious. Another instance is just where the uncertainty just prevents new knowledge from being created. I would emphasize that a lot of the things that we're going to talk about, data science in the ideal versus data science in real life, is covered in week 4, the 4th class of the specialization called Data Science in Real Life. So in this lecture, I'd just like to go over some examples of when data science was a real success, and maybe some examples where data science wasn't so successful. Well, actually, I don't think I cover anywhere it wasn't so successful, but I cover an instance where some negative things happen. I think if anyone were to ask anyone about defining success in data science, the first thing that comes to everyone's mind is Moneyball. And if you haven't heard of Moneyball, and I promise I'll have some other examples as well. But if you haven't heard of Moneyball was this brilliant novel written by Michael Lewis on the Oakland A's baseball team and their manager, and how they started using data science to help them improve their performance. And here's this great plot from 538 where it shows the standard deviations from the average payroll of the teams versus the win percentage. So if you look at Oakland, the clear outlier of this relationship, it's one standard deviation below the average payroll. It is well above what would be expected for the win percentage for that team. Now, it's not the best. Way up in the right is the New York Yankees or the Red Sox or something. I think it was the Yankees in the upper right that had the highest payroll and the highest win percentage. But Oakland was well above what would be predicted from them based on using data science in their organization. Okay, so that's a very famous example. Now, if you haven't read that book, it's a great motivating book for the field of data science. But I want to cover one of my favorite examples of a data scientist, maybe one of the earliest examples of a data scientist, and that was Florence Nightingale. So you've probably all heard of Florence Nightingale in her fabulous work as a nurse, but you may have less likely have heard of her contributions to the field of statistics and graphics. And this is one of her beautiful graphs that she created here. She's one of the really early developers of modern graphs. And anyway, there's a lot written about it in some of the books, like Tufte's books on graphing. And it's great reading if you want something interesting to read up on. But in this particular graph and in this set of work, she showed that the British soldiers in the Crimean War, were more likely to die from cholera than they were to die on the battlefield. And this was in a report that she gave to the royalty that actually changed policy. So this is a great example of using data, creating visualizations, and an early example of data science to impact policy. And I would say this idea of using data science to inform infectious disease prevention is very old and has had its ups and downs. And so let's talk about one of the downs. Another one of my heroes is this person right here, Semmelweis. Semmelweis was a physician, but he was also a very astute scientist. And he was concerned about the rates of infections when contrasting two clinics in his area, two clinics for pregnant women. And he wanted to figure out why the outcomes were so much worse for one of the clinics. And he used the data, and he used a lot of scientific and critical thinking to figure out, well before the advent of the germ theory of disease, that it was the fact that the medical students were operating on the cadavers and then treating the women were actually carrying over some sort of infection, or he called it something with the word cadaver in it, some sort of cadaverous infection, because they hadn't, this was before the germ theory of disease. So at any rate, what's negative about this, I mentioned that this was negative. What was negative about this was that, and his solution was hand washing. And what was negative about this was that policies about hand washing weren't executed till well after this research, well after his death. Even now, there's still a lot of work being done trying to enforce hand washing in hospitals to prevent infections. So his work has this long legacy, and this long legacy that's still being researched, and unfortunately it was a long time and a lot of lives were lost by virtue of ignoring what was clear data, and especially even if this data wasn't the clearest data, the data piled up on top of it afterwards. And so this maybe wasn't the best example of the successful outcome of a data science experiment, despite the experiment actually being conducted well. I wanted to also talk about another instance from an alumni from our department, this physician here named Dory Sagan, who actually also got a master's degree in biostatistics along the way. And he has several great examples of using data science to inform decisions in policy making. So in one example, and I would say what his career seems to be shaping up as, from my outside viewpoint, is he's applying the field of data science to transplantation research, whereas traditional transplantation research was really all about improving technique, for example. He's really working on databases and performing a lot of statistics on large populations of transplant recipients and donors, etc., and really impacting policy. So in essence, he's moneyballing transplantation in a lot of ways. And one really great success he had was to help get policies enacted to allow for HIV positive patients to be donors just for research purposes, to understand whether or not they can be donors to other HIV potential kidney recipients. And so this was, he did some data science work on estimating the potential pool of HIV-infected deceased organ donors, and this led to new legislation, and here's President Obama signing it, this is going to allow researchers to study this phenomenon and may, in the long run, save quite a few lives. I would say, also, here's this, I put a link here, here's this cute documentary created by Andrew Rosario on Dory and his wife, who's a computer scientist at the Naval Academy, and on the problem I'm about to talk about, which is another really great data science success. So watch this YouTube documentary, it's really great. So at any rate, another thing that they studied was considering this problem. So here I have two shades of red. The first row is a couple. The left member of the couple, let's say they're spouses, the left member of the couple wants to donate a kidney to the right member of the couple. And the same thing is true for the second row. However, they're not matches, so they can't be donors. However, imagine the case that the pair of them could be donors to the others, and you can imagine mining a data set to do this. Then you could put everyone under the knife at the same time and do the donation, do the donation this way, so the second spouse gives it to the first first spouse's recipient and vice versa. And there's nothing that would stop you from stopping at pairs of kidney donation. You could, for example, do 3 where none of the pairs would match up, but if you had 3 that matched up in the right way, you could do it. Well, Summer, his wife, who's the computer scientist at the Naval Academy, wrote the algorithms that mined the donation data set to find, and the potential donors, to find large collections of matches of pairs of kidney matches in ways that would work out. And Dory and other members of the transplant teams here at Johns Hopkins have done extremely large multi-way simultaneous kidney transplantations. Many of them were reported on the New York Times. So I think this idea of moneyballing transplantation is really transforming the field, and it's really and I have to say, it's just great to see one of our alumni, even if we were only a minor part of his education, doing such great work, and especially applying biostatistics and data science in such a profound way. I want to talk, this is another example from biostatistics, an example where the measurement can't do what you'd hope for. And this is my friend and colleague Martin Linquist. We work in the field of fMRI, and something that a lot of people want to do is say, when this area of the brain activates, then afterwards this area of the brain activates. And what Martin basically proved, using a collection of data science, physics, and biology, was he showed that that's not actually possible with the measurements that are being collected. So that's a negative result in a sense, because what everyone wants to do has been proven can't be done. However, in a positive sense, this has shed light on, not wasted a lot of people's time now trying to do this, and it was an important result. And also, people who wanted to do this have, continued to try to refine the technique, the way in which the data was collected, to improve it. So I just want to reiterate this point, that another way in which success can occur in data science is if you can demonstrate that you can't answer the kinds of questions that you want to with the data that you have available to you. And I want to end on a more positive note, that on this idea of impact. And one of the best ways that a data science experiment can have impact is if the product of the data science experiment is some app that everyone uses. And I just want to make a plug for my own class and the other Coursera data science specialization that we teach, called Data Products, Developing Data Products. And in the data product class, you create an app, a data science app, and sometimes people tweet them out on Twitter. If you go to #MyDataProduct, you can see some of them. Here, I took this one from this one that I liked. I picked one relatively at random, but I liked it because it had lots of dials and inputs. Where this student Brent put in, you can put in a lot of various factors and get your retirement savings, get a retirement savings goal out of it. So, and at any rate, some of the, of course, some of the most well-known examples of data science apps are all the recommender systems that occur when we purchase goods from online retailers and things like that. So one of the best ways to have an impact is to create an app, and we're seeing that so often now in our lives, it's hard to even enumerate them all. I think it's hard to even go through a day without using a data science app. Okay, so in today's lecture, we talked a lot about different ways in which data science can be successful, and maybe even a few where it can be a little less successful. If you want a lot more discussion about what to do when your data science experiment is a little bit foggier, the week 4 class, Data Science in Real Life, will cover that. However, in this case, I hope this gets you thinking about, for your own data science experiments and the ones that you're managing, what would define success. Thanks, and I look forward to seeing you in some of the next lectures.